Lipids, like the cheese in your sandwich, also begin to be digested in the mouth, where salivary lipases start that breakdown process. But lipids are much more difficult to digest, mostly because they're not water soluble. Most lipid digestion occurs in the small intestines because we need both bile from the liver and pancreatic lipases to break down fats. Bile contains the things that are necessary for lipid digestion. Bile's mostly made of cholesterol because like dissolves like. If we want to, quote, dissolve fats that we're eating, we're going to need a similar substance to do the dissolving. Bilirubin is a pigment that gives mostly a yellow, sometimes a brownish color. You may associate diseases with the liver with the skin condition jaundice. Yes, jaundice results from inappropriate recycling of your bile, right? So that bilirubin builds up in tissues of the body instead of being built up in the liver. So what happens is instead of excess bile going to the feces and leaving the body, it's retained in the liver. When the liver surpasses its storage space for bilirubin, it will start to accumulate that bilirubin in other parts of the body. Bile also contains salts that emulsify fats. The word emulsify means to combine two or more liquids together that don't easily mix, like oil and water. In fact, emulsifying is what you do to make a good salad dressing. You have to use the blender to cut up the oil as you add the vinegar to it. Dawn dish soap has a claim on its label calling it a powerful emulsifier. It is. Dawn dish soap is used on wildlife that's covered in oil and other nonpolar substances from human activity. The bile salts in your bile act like dishwashing detergent, like Dawn, breaking up the fats into very small lipid balls that then get trapped in these little phospholipid bubbles called micelles. This process of breaking down a fat with bile salts into micelles, that's only mechanical digestion, because all we're doing is just making it smaller. We're not actually ripping atoms and molecules off of it. All of this mechanical digestion makes it much easier for the pancreatic lipases to do that chemical digestion of the triglycerides and the lipid. That is where the next accessory organ, the pancreas, gets involved. The pancreas releases pancreatic lipases, which facilitate the breaking down of fatty acids from the triglycerol. Lipid digestion occurs very differently than carbohydrate or protein digestion. With carbs and proteins, the breakdown products are able to be transported across the epithelium of the small intestine and enter into venules that are present in a villus, such as the one pictured here. So small, polar breakdown products enter this venule, and then they're transported to the liver by way of the hepatic portal vein. Lipids are transported through the epithelial cells of the small intestine's ileum, but they don't enter into the venule, they enter into this lacteal. Lacteals are present in the small intestine villi, and they're able to absorb large nonpolar substances that the venule can't, like lipids. This lacteal, and all small intestine lacteals, are basically lymphatic vessels, right? And they all converge and dump their contents into the subclavian vein. I know, you're like, we're bypassing the liver? Kind of. Bile salts have emulsified the lipid at this point, and smaller lipid droplets are now sequestered in micelles, along with lipid-soluble vitamins and maybe some excess cholesterol that was used to emulsify the lipid. Micelles are pretty cool substances, actually. They're arranged like a lipid unilayer, not bilayer. They form just one row of phospholipids with their polar heads facing the outside aqueous environment and with the nonpolar tails facing the lipid and cholesterol on the inside. I have a makeup remover that calls itself a micellar makeup remover. Mascara is a lipid, coats your eyelashes. Many eyeshadows, especially those found in stick form these days, are also lipid-based products. Mycels are organized such that the water-soluble portions face the outside and the lipid-soluble portions face the inside. And this allows mycels to readily interact with the epithelial cells of your small intestine. Mycels and cell membranes are both made up of phospholipids. So when a mycel comes into contact with an epithelial cell of the small intestine, they kind of like fuse together. And the inside of the mycel just dumps out or diffuses into the epithelial cell. The cell is like, whoa, whoa, whoa. And what it does is it forms a water-soluble lipoprotein, which is called a chylomicron. Chylomicrons are then transferred to the lacteal, not to the venule, to the lacteal. Chylomicrons are packaged, like wrapped, in proteins, giving them the name lipoproteins. At first, low-density lipoproteins are formed in your small intestine, LDLs. Chylomicrons are then given to the lymph or the lacteal, and they give the lymph fluid a really milky appearance. So we call lymph that's contained in lacteals, we call that chyle. Chyle, like all lymph, is dumped into general circulation by way of the subclavian vein. Chylomicrons, they then travel to cells where the fatty acids within can be used for generating ATP. As the chylomicrons lose fatty acids, they lose their contents, they become more and more dense. And then they form high-density lipoproteins, or HDLs, which then deposit in your arteries, like mine. Most of this process that we just described, the lipid metabolism, occurs in the ileum. It's the last portion of the small intestine. It's the last place that you can extract any nutrients. So any unabsorbed fat is just shunted out with feces, which results in that brownish color from the bilirubin. The common hepatic duct drains the bile from all of the bile ductules in the liver. Most bile is shunted through the cystic duct, which is the duct that connects the common bile duct to the gallbladder. Bile is usually stored in the gallbladder until needed. When it's needed, the gallbladder has smooth muscle that can make contractions, pushing the bile through the cystic duct and into the bile duct, which joins with the pancreatic duct. At this point, the fluids from the pancreas containing tons of digestive enzymes and the bile from the liver, meant to help with the processing of fats, gets gathered together at the hepatopancreatic sphincter, which is a valve closely regulating the spewing of the contents into the small intestine. The hepatopancreatic ampulla is the opening that connects the plumbing from these accessory organs and the small intestine itself. Something that you may not have noticed is that the bile ducting in the liver is not a circulatory system. The bile is drained from the liver and injected into the small intestine. If it's not used, then it leaves the body by way of feces. If it is used, the bile actually makes its way back to the liver and thus is recycled to emulsify fats in a new day. After being stored, bile is injected into the small intestine to help with that lipid metabolism. If a person's gallbladder is removed, sometimes the cystic duct will enlarge and function as a new gallbladder. The gallbladder, it not just stores bile, but it also concentrates the bile, dehydrating it, removing any water. This is how gallstones can form. Gallstones are basically little rocks of bile salts. These little rocks, they don't flow out of the gallbladder, they just accumulate. And as more and more of them accumulate in there, it causes some pretty intense pain, from what I'm told.